as well. So this session is going to be very focused on the workings of the AWS Key Management Service, known as KMS, and how it's used to protect your data through encryption. So a little bit about myself first. I'm the AWS Content and Security Lead for Cloud Academy, where I've created over 90 courses on different AWS topics, and these courses have reached well over 100,000 students. I'm also a part of the AWS Community Builders program, and I've just published a new book, the AWS Certified Security Specialist Exam Guide, which helps you prepare for that very certification. Okay, so there's a few things that I want to cover today, starting with an overview of the AWS KMS service, just so we all have a baseline on the service before I start diving deeper into different topics. I'll then take a look at some of the components of KMS, these being the customer master keys, the data encryption keys, key policies, and also finally a look at grants. And then once we've established an understanding of these elements, I then want to give a demonstration on how we can share CMKs between multiple accounts, which many of us are probably running in production environments. And you might want to do this if you are centralizing your security controls from a single secure account. And in this instance, you'll be centralizing the management of your encryption keys. So let's get straight into it. So what is KMS? Basically, the key management service is used to store and generate encryption keys that can be used by other AWS services and your applications as well to encrypt your data at rest. So it's not used for in-transit encryption. So it's a fundamental security service that's offered by AWS to help you manage your entire cryptographic operations across your data. Now, there are different types of keys used within KMS which perform different roles and functions, and I'll go into detail on these different key types as we go through this session, because there can be confusion over them sometimes. And now some people think that AWS have full control of our keys, but in actual fact, they don't. So it's down to us as the customer to ensure we secure them through key policies. And I'll be talking more about these later. Now, we must control who has access to these keys and the cryptographic operations that can be performed with them. And as a part of this, key administration is very important because AWS do not have access to your keys, and therefore, if you delete them by accident, they cannot recover them. Now, KMS also integrates with a wide scope of different AWS services to provide that at-rest encryption to protect your data. And to aid compliance, KMS also works seamlessly with AWS CloudTrail to audit and track how your encryption keys are being used and by who. And finally, KMS is not a multi-regional service like IAM is, for example. It is region-specific. So if you create one key in one region, then you can't use that same key in a different region. Okay, so let's now take a look at some of the core components and features that make up the KMS service. And it's primarily based around the 4 different options you see at the top of the screen there. So we have our customer master keys, our CMKs, our data encryption keys, which is DEK, key policies, and also grants. Now, let me start off by explaining the CMK, the customer master key. Now, this is the main key type within KMS, and it contains the key material that is used to encrypt your data. And there are 3 different types of CMK, and it's important to know the difference between them. We have customer managed, AWS managed, and AWS owned. And on the next slide, I'll be diving into each of these keys to give you more insight into what each CMK offers against the other. And another point is that the CMK never leaves KMS. It is created within KMS and remains within KMS at all times. But the CMK can generate your data encryption keys, and these DEKs can leave the KMS service, and they are used by other AWS services to implement encryption across your data. So the first CMK I want to highlight is the customer managed CMK. Now, these keys offer the greatest level of flexibility and control across the 3 key types. You are able to create, disable, and delete the key, configure the key policies associated with your key, configure grants, and also alter and adjust the key rotation periods and view the full usage history of that key. Now, these keys can be used by other AWS services that integrate with KMS. But one thing to bear in mind is that due to the additional flexibility offered with the customer managed keys, there is an additional charge for creating your customer managed CMKs. Now, next we have AWS managed CMKs. So these keys, as the name suggests, are managed by AWS. However, you are still able to view these keys within the management console and also order and track their usage. And you also view their key policies as well. But because they are managed by AWS, it's not possible to modify those key policies. And also you can't control their rotation frequency either. So these keys are created and used by AWS services that integrate with KMS directly, but they can only be used by the service that creates them. And it's easily to identify AWS managed CMKs by their alias. For example, if you see the key AWS/S3, then this is an AWS managed key used for S3 encryption only. Or if you see AWS/EBS, then this key would be used by the EBS service. And then finally, you have AWS owned CMKs. Now, these are not visible within the KMS console or anywhere within your account. Neither do you have the ability to order and track their usage. They are essentially abstracted from your AWS account. But of course, there are some services that use this key type to encrypt your data within your account. Now, a couple of examples of AWS owned CMKs include the S3 master key when using SSE S3 encryption, and I'll show you this a bit later in the demonstration, and also the default encryption option used on all Amazon DynamoDB tables that also uses an AWS owned CMK. So let's now look at data encryption keys. Data encryption keys are created by CMKs, like I mentioned earlier. However, they are used outside of KMS to perform encryption against your data. Now, either in your own applications or by other AWS services. So when a request to generate a data key is received by KMS, the associated CMK in the request will create two identical encryption keys. One of these will be a plain text key and the other will be an encrypted key. Now, during the encryption process, it's the plain text key that will be used to perform the encryption of your data using an encryption algorithm. And then once the encryption has taken place, this plain text data key will be deleted and the encrypted data key will be stored and associated with the newly encrypted data. Now, to demonstrate an example of DEKs being used within AWS services, let me take a quick walkthrough at how encryption and decryption process works for Amazon S3 server-side encryption with KMS managed keys, known as SSE KMS. So you can see here, at the top we have the encryption process, and at the bottom we have the decryption. Now, at the top there's essentially 5 different steps which I've highlighted with those yellow dots. So let me just walk through those quickly. So number 1, firstly, the client will upload an object to S3 indicating SSE KMS as the encryption mechanism with a specified CMK. Number 2, S3 will respond by initiating a request to generate data encryption keys from KMS. Number 3, KMS will then generate 2 data encryption keys. One of these will be a plain text and an encrypted version of that same key. Number 4, KMS will then send both of these data keys back to S3. Now at stage 5, S3 will then encrypt the object data with the plain text version of that data key and store the resulting encrypting object alongside the encrypted data key. And then the plain text data key is then deleted from memory. I mean, there's quite a lot to take in there, but hopefully it's kind of fairly easy to follow through when you break it down. Now, from a decryption process, let's run through that as well. And here we have 6 different points. So number 1, when decrypting the object, a request is received by S3 to access an encrypted object via a client. Number 2, S3 sends the encrypted data key that was associated with that object to KMS. Number 3, KMS then takes that encrypted data key and uses the original CMK to decrypt that data key and generate a plaintext version of that data key. Number 4, KMS will then send that plaintext data key back to S3. Number 5, using the plaintext data key, the encrypted object data can then be decrypted, returning a plaintext version of the object data, and then the plaintext data key is then removed. And finally, number 6, the plaintext version of the object is then returned to the client. So that's how DEKs work in conjunction with CMKs. So now looking at securing access to the CMK itself via key policies. So key policies determine who can do what with a key. For example, defining who can use the key to perform cryptographic operations, in addition to those who could administer the key to perform functions such as deleting and revoking the key. So controlling access to CMKs can't be done using IAM alone. In all cases, to manage access to your CMKs, you must use a key policy. And there are a number of different ways in which you can control access to the CMK. These being via key policies only, via key policies and IAM, and via key policies and grants. So let's take a look. So the first option is via key policies only. So as I just mentioned, key policies determine who can do what with a key, and these functions are split between administrators and users. Now on the left, we can see key administrators and the actions that they can perform. Now note that administrators are not able to perform cryptographic operations. And then on the right-hand side, we can see the key users. And the users identified here in this section of the policy can perform cryptographic operations. So there's two very distinct roles as part of the key policy. So let's now look at control access via the key policy and IAM. Now, every time a new CMK is created, the root of the account in which the CMK is created in will always have full access to the CMK. Now, this provides two benefits. Firstly, it ensures that you will always have administrator access to the CMK because the root account can't be deleted. And then secondly, it enables you to use IAM policies to grant access to the CMK for both administrators and users. And you can see in the SID, in the example here at the top of the statement, that it reads enable IAM user permissions. And without this section, it would not be possible to use IAM permissions to grant access to your CMK. And then finally, we have access via key policies and grants. So grants allow you to programmatically delegate your permissions to another principal or user. And so the grant consists of two parties. It will be the user who actually creates the grant, and then the grantee who then uses that grant to perform cryptographic operations. So for a user to be able to create and revoke grants, they must have permissions shown on the screen here. So for example, KMS create grant, KMS list grants, and KMS revoke grant. Let's take a closer look at grants if you're unfamiliar with them. So as we already know, the grants allow you to delegate your permissions between two people. Another point to make is that grants can only be created programmatically, so you can use the AWS CLI, but not the management console. So let's look at a quick example in the yellow below. So this command simply creates a grant using the ARN of the CMK as the key ID, allowing the principal Alice to receive both encrypt and decrypt access. And the result of this command generates two items, a token and a grant ID, which can then be used by Alice to perform these cryptographic operations programmatically. So I'm about to show a demonstration, but just before that, to give permission to use a CMK to users and roles in another account, you must use two different types of policies. So as we know, we must use the key policy for the CMK, and this must give the external account permission to use that CMK, and then policies in the external account must delegate those same permissions to its users or roles. So the goal of this demonstration I'm about to show you is to allow a user called Amsterdam in account B to use a CMK in account A to upload an object to S3 using SSE KMS encryption. Okay, so let's take a look. So I'm in my account A at the moment, and I'm in the KMS dashboard. And here we have our customer managed keys. So I'm going to create a customer managed key because you can only allow access, cross-account access via KMS keys that you create. We have our AWS managed keys here, and here are the alias of those keys, like I mentioned earlier. So it's very easy to see which key is used for which service. But I'm going to create a customer managed key. So if I click on create key, just create a symmetric key and use KMS as the key material origin. Just give this a name, just call this demo. Now here I can select my key administrators. So I can select whoever I need to be an administrator of this key, which, as I explained earlier, can revoke or delete the key. Click on next. And here I can define key usage permissions. So I can specify who's going to be the user of this key. So I can just add any users I want. Now at the bottom here, you can see that I can add another AWS account. If you're creating a new key, then you can do this here, but many of you might already have CMKs already created. So I want to show you how to add access to another account by editing the key policy directly. So click on next. And now here we have our key policy. So at the top, we have that entry that's automatically added that enables IAM user permissions and gives the root account full access. And then we have our key administrators. So they're the two users that I selected. And here's all of their actions. And then we have the users of the key as well, and the actions that they have. So let's finish. So now we have our demo CMK. But what I want to do now is to edit the key policy. So select key policy and then go across to switch to policy view and then edit. What I want to do is scroll down to the key users because I want to allow a user in another account. So let me just add that user in. So just put in the account number that they exist in, 3569 312 8354. I hope I have that right. And the user is Amsterdam. Okay. So here's the current account that I'm in, and here's the account number of the user Amsterdam. So save changes. Okay, so now I've created that customer managed key and added that user to the key policy. I now need to switch over to the other account. So let me log in as the user Amsterdam. Now, what I want to show you first is that this user does not have access to use this key at the moment. So if I go to S3 and just quickly demonstrate that. Now I have a bucket here that I've created called Amsterdam KMS. There's no objects in here at the minute. So I'm just going to upload any file. Just a screenshot is fine. Click on next. Just take the defaults here. And then when we get to the storage class screen, we can scroll down and here we see our encryption options. So we can have no encryption. Now here's the Amazon S3 master key. So this is the AWS owned managed key. So I don't actually specify the key there. I have no option to view that key or anything like that. So that's the AWS owned key that I mentioned earlier. Or we can use the AWS KMS master key. So here we select a custom KMS ARN. So if I go back and get the ARN of our key that we created, which is here, copy that, paste that in here. So we have the key from account A. And if I say upload, this should fail. And then we have an error, 100% failed. View details, it's forbidden. And that's because we haven't delegated that same access for within the key policy for this user. So let me go ahead and do that now. So if I go to IAM, and if I select the user Amsterdam, once it's loaded, so here we have the user. And I'm going to add an inline policy. Go straight to JSON. Now, I've already created a policy earlier for speed because we don't have much time. So I'm just going to replace that with this policy. And what this policy does, it allows the use of the CMK in my account A for this user to give them cryptographic operations. But I need to add in the resource. So I need to get that ARN again, copy that. So here's the ARN of the key in the primary account. So now with an inline policy, this user, Amsterdam, should have access to perform cryptographic operations. So if I just review that. Just give that a name, create the policy. And we can see here now that we have this inline policy. So now if I go back to S3 and try that upload again, we should be successful, hopefully. So if we go to upload, add files, select any file, accept the defaults there. And then again, when we get down here, we can specify our encryption mechanism, put in the ARN of the key in account A and click upload. And there we go, we have success. So if I select this object, we can see that it's being uploaded with a standard storage class using AWS KMS encryption, server-side encryption, and also the key that was used as well. And we can see here that this is the account A, it's different to my account here that I'm using. So that's how you can share CMKs between multiple accounts. So that was a very quick tour of KMS, some of its components, the different types of keys and CMKs that are available. And hopefully that's provided some insight into the service and has answered some of your questions that you may have had about KMS. I was contacted during the week asking if I could demystify some of the differences between the AWS CMKs. So I hope this session has answered that question. And if you have any more questions that come up to you later today after this session, then please do reach out to me using the details shown on the screen, either on LinkedIn or Twitter, and I'll be happy to answer any questions that you may have. So that's it for me. Thank you for listening. And thank you, Walter, for the opportunity today. It's been fun. Thank you very much.
Yeah, thank you very much for being with us. And it's one of those topics that seems relatively simple, but when you get to the nitty gritty of it, there's actually quite a few details.
There's a few different options. That's right. Yeah.
Yeah. So we have a number of questions. So we have like 7 minutes. So I'll go through some of the questions real quick.
Sure.
One of the questions is Anton Peters asks, if the master private key is on AWS, I as a customer am not really in possession and control. I think it's more a statement than a question.
Yeah, so you can use, within KMS, you can use a cloud HSM cluster where you can have more control over the key material that you want to use. And sometimes this is a regulatory and compliance requirement where you are asked to ensure that you have more control over the key material being used, and using a cloud HSM cluster as your source can be a good way to ensure you have more control over that.
Yeah, I mean, if you involve the cloud HSM stuff into this conversation, it gets another level of complexity.
Yeah, we'll stay out of that.
But yeah, that's definitely a way to look at making things even more secure, and sometimes regulatory compliance demands that. Yeah. The next question is, if KMS is region specific, how it can be used in architectures with cross-region requirements? It's a good question. So
you can copy cross-region replication with KMS keys. Actually, I just want to show something quickly. So during the presentation, I showed an infographic which showed SSE S3. So you can go to this URL here and get information on lots of the other S3 encryption mechanisms. So server-side encryption just using the master key, KMS, or client-side, and also client-side encryption here. And there's also a quick, let me just zoom in a little bit here.
Cross-region replication.
Quick explanation on how cross-region replication works with KMS and S3 as well. So, I won't dive into the big details of it due to time, but do please take a look at this infographic that I created. It should help cover a lot of the areas that you have with regards to KMS, specifically around S3. So yeah, feel free to take a look at that. It can help you understand the inner workings of what actually is going on. And I've created an encryption and decryption version for all of them.
Awesome. And the last one is, could you please provide the most common use cases for key policies, grants, and IAM to manage access control for this KMS CMK? It's quite a lengthy question. Maybe you can,
yeah, I think most people, yeah. So like I say, you can manage access to your CMK multiple different ways. Most people tend to use IAM because they have a very centralized access control system. Administrators are very familiar with using IAM, and you can centralize access to your keys that way, rather than just using a key policy, which you don't have. Not all the administrators might have insight into each key that you create. If they all have their own individual key policies, it's easier to manage access through IAM. With regards to grants, that can just be used as a temporary access. So if someone in your team just needs a temporary amount of access to perform encryption using a CMK, you can then delegate your own permissions as long as you have access to create grants to someone else. And it has to be, those permissions can only be equal or as a subset of your own permissions. So if you only had encrypt permissions and you created a grant, you can't then delegate encrypt and decrypt permissions to someone else because you don't have that decrypt access. So grants tend to be used for kind of a temporary access where you can just grant someone else access of what you have temporarily.
Yeah. Okay. Awesome. Stuart, I'm terribly sorry, but in about 2 minutes, I'm needed downstairs in the studio for the main track to continue. So if anybody has more questions, you can see where you can reach Stuart. Thank you very much for your for your
reach out to me.
I'm going to run downstairs.
Great. Thank you very much, also. Appreciate it.
Awesome.
Thank you.
Thanks, Stuart. Bye.
Cheers. Bye.